Okay, so we are finishing up 6-1 today. And as I said, we're going to start talking about geometry concepts we can use with radians. So first thing we need to talk about is if I have something like this that is badly off. All right, let's try that again. So if I'm working with the circle, okay, and I want to find that angle, okay, we would call this, does anyone remember from geometry what type of angle that is? It is obtuse, but it's also called, inside of a circle, we call it a central angle, okay? Interior angles inside of a circle are called central, okay? And when we're talking about a central angle, it's any angle inside of a circle. So we could have, this is also we could call this theta 1. And then we could have a third angle here that we call theta 3 or something like that. The biggest thing with central angles is what do central angles have to sum to? 360 degrees. Or in radians, from what we talked about yesterday, what is? Good. Okay, so we can find, again, central angles can be found just like what we talked about yesterday, can be found as degrees or in radians. Okay, and we will interchange and use both of those. Okay, so that is a central angle. All right, so what we're going to talk about today using central angles is what if looking at angle theta, what if I want to find the length of just that part of the outside of the circle? Does anyone remember what that would be called from geometry? Starts with an A. Anybody? Not area. We call those arcs. Arcs. Okay? So when we're looking at this, we have an angle, and then we have what's called the arc, which is the section of the exterior of the circle that's intercepted by that angle. Okay? And in this case, like we said, we call this an arc. Okay? So to find an arc, it's really part of what? What do we call, if I find the distance all the way around the outside of a circle? Perimeter, which we call circumference with the circle, right? And remember we talked about yesterday, the formula for circumference is 2 pi times radius. Well, where does 2 pi come from? One full rotation on the unit circle. Okay? So it's one full rotation times the radius. That's circumference. But now, is my arc all the way around? No. My arc is only partial. So we use this formula to find arc length. So if I'm trying to find the length of this arc, for some reason, the Greek for arc length starts with the letter S, so we use S to denote arc length. And then it is the radius times theta. And whenever I give you an angle as theta, like in this case, you need to assume this is in radians. Okay? So the formula is different if I give it to you in radians versus degrees. Okay? The formula is different if I give it to you in degrees. And just so you're aware what that formula looks like, it's your angle divided by 360 times r is the formula in degrees. Okay? Angle divided by 360 times r. Whereas in radians, you can just take r times theta. Which is why, to me, if I had to memorize a formula, I'm going to memorize this one because it's shorter and its uses are more universal. So when we're trying to find arc length, that is the formula we want to know. Where again, And when I say radians, that's the radians of our central angle. So radius times radians of our central angle. And just to make sure we're all on the same page, what is a radius? Halfway across a circle, right? From the center to the edge of a circle is a radius. What do we call it all the way across? Diameter. Okay, good. We're on the same page. All right, so let's do an example. Given a central angle of 128 degrees, find the length of an intercepted arc Find the length of an intercepted arc in a circle with a radius of 5 centimeters. Okay? Bless you.
So we have to change 128 to 80?
Correct. So the first thing we have to do in a problem like this, I'm giving you an angle in degrees. Giving you an angle in degrees. Well, the formula we talked about is not in degrees, it's in radians. So the first thing we have to do is convert the 128 degrees to radians. And what's our conversion from degrees to radians?
2 pi over 360.
2 pi over 360. You can also use pi over 180. Okay? So to find theta, we're going to take 128 degrees times pi over 180. Which, as we talked about yesterday, you have to convert these into fractions. And then we need to multiply straight across. Again, can you use a calculator for this?
No.
No. Okay? Now, what can both these divide by? 2. So we get 64 pi over 90. Now, can you use a calculator to help with this part? Yes, but I don't want you to just plug this straight in. Divide by 2 again. 32 pi over 45. I think that's it. Yep. So that's our theta. 32 pi over 45. And then, what's our radius? 5. So once I get that, I just take 5 centimeters times 32 pi over 45. And if I multiply that out, 32 times, well, actually, 5 over 1. What can I do to those fractions before I even multiply? Can I cross simplify?
Yeah.
What can I divide?
5.
The 5 and the 45, right? Make the 5 a 1. 45 divided by 5 is 9. Right? Is that right?
Yeah.
Okay. And so I just get 32 pi over 9 centimeters. And this is arc length, so it's not centimeters squared. No, it's just centimeters. Okay? Now, with that, do I care if you take that to a decimal? Not at all. If you take that to a decimal, I get 11.2 centimeters. Correct. Okay? If it's a distance, and at the end, I don't care if you round. Where I don't want you to round is finding theta. Okay? Wait until the end to round. Because if you round when you find theta, and then you round again when you find your answer, you've rounded twice. So how accurate is your answer? Not very. Okay? Just like how you talk with sig figs, you wait and do all of your sig fig at the end in chemistry, right? Same concept here. Only round once. Okay? Questions on that? Does that make sense? All right, let's do one more. Let's do one more. All right. So I'm going to give you the angle and the radius, and you find the arc length. So find the arc length of a central angle being 210 degrees with an intercepted arc of a circle with a radius of 8 inches. So work through this, then I want you to compare your answer with somebody you're sitting by. Make sure you get the same thing. Again, remember the process. What's your first step?
Well, you convert it to radians. Five or one pi over 180. So it's either pi over 180, which is fine, or you do 2 pi over 360. Either way is fine. I don't care which one you do.
Make sure you simplify theta before you plug it into your equation. If you memorized your radians from the unit circle yesterday, you should be in pretty good shape as far as finding theta. Or if you have your unit circle from yesterday.
I have a question. So why is the 360 fewer than 180? Why can't I find
So
my pi?
this is to find.
I'm not done. I can't. Where's my pi?
Yeah, that's not it. Ignore that for now. We'll come back to that.
Okay.
Your pi key.
No.
Well, that's 56. Oh yeah, you can.
It's a
Yeah.
syntax thing.
You can.
Okay, give you about 30 more seconds. 30 more seconds.
You just do 28 divided by 3.
Check. 8 times 7. Now, could you
I
cross
simplified.
or even multiply?
I cross.
Or you don't have to.
It's 28.
Yes. What?
Wait, so is that? So 6 5 over 6. How about you?
3.1.
Oh, wait, never mind.
It doesn't repeat.
Yeah. Okay, so first thing, how many of you went back to the unit circle from yesterday to find 210? No? We all converted? Okay. So if you remember from yesterday, all right, bring it back in, please. So if you remember from yesterday when we talked about the unit circle, 210 is 7 pi over 6, right? So that's where we talked about if you memorize the unit circle, that helps quite a bit when it's asking you to convert. Now, do you have to do it that way? No. You can still take 210, multiply it by our conversion factor, which is the pi over 180, or 2 pi over 360, and I get 210 pi over 180. What can I divide those both by? 10 and in 0. Good. Then 3. So 7 pi over 6. There's my theta in simplified form. Then again, r times theta. Radius is 8 inches times 7 pi over 6 radians. Now, can I simplify it all? Cross simplify here. You don't have to. Could I simplify this to a 4 and that to a 3? Yeah. If you don't simplify, you get 56 pi over 6, which then you can divide both by 2, and you get 28 pi over 3. Now, some of you said, well, I think I did it wrong, and you took that down to 9.3 repeating pi. Do I care if you do that? Not really. Is that not saying the exact same thing? Yes. 9 1/3 is 9.3 repeating. That's fine. Personally, I want it left like this, or if you're going to take it to a decimal, take the whole thing to a decimal. So 28 pi divided by 3. 29.3, and what's my unit? Inches. So if you're going to take it all the way, take it all the way. Okay, if you're going to put part of it as a decimal, be consistent. Make the whole thing a decimal. Do I care which one of these two you give me as an answer? No. Is this right? Kind of. But is the answer in those terms? No. So if you get there, just simplify the fraction, take it one step further.
If you get there though, you can just,
Divide by 2.
well, you can just do the D6 pi divided by 6. So
100%. And you still get 29.3. Yep. So if you want to take it to a decimal, yeah, I don't care which one of those you use. Okay? All right. So that is arc length. Any questions on arc length before we move on to finding area of sectors?
Let's just stay on that forever.
Okay? So, coming back to what we started with. So, we talked about that's a central angle. We said that if I want to find this, that's an arc length. Okay? Theta, there's a central angle. Well, what if I want to find that whole thing? Part of a circle. That we call a sector. And when we're doing this, what we're doing is finding what's called area of a sector. Okay? Now, the process, not much different than what we just did. It's really not that much different. So if we think we talked about circumference was 2 pi r. And we said that, all right, well, I'm just taking part of 2 pi times my radius. What's area of a circle? What's the equation? Nope, not 1/2.
It's radius pi.
It's just pi r squared. Pi times radius squared. Okay? So, using that concept, this is if it's a whole circle, not part of it. So, to do a sector, area of a sector, the formula is 1/2. It's still the radius squared times theta. So the r squared still comes from this idea. I'm still finding area, and if we're finding area, I have to square the radius. But now I'm not finding the whole circle, I'm finding part of it. So instead of just doing pi r squared, I'm taking theta, which has a pi in it of some kind, and I'm multiplying it by 1/2. Okay? So, and again, what is theta assuming? That the angle is in what? Radians. So if it's not radians, what's the first thing you have to do?
Convert it.
Convert it. Okay? All right, I'm just going to turn you loose with an example and see if we can do it. So if I have a central angle of 5 pi over 6, I'm being nice this time. I'll give it to you in radians. And the radius of our circle is 16 centimeters. Find the area of the given sector. All right, find the area of the given sector. Central angle of 5 pi over 6. radius of 16 centimeters. Using the area of a sector formula, which is right here, find the area. And you will want a calculator for this. Also think about your unit, what that should look like. Centimeters, but it's area, so.
I feel like there's something. I'm not done yet, but I'm having some radius like this. I'm scared. 335. Wait.
So what?
Whoa, what?
Kyle.
Yeah, you can take it to a decimal.
335? Look what numbers I got, so.
335.
Can you look at mine? Because I did something wrong.
325.
Did you square it?
Oh,
Took 16 times 16. Oh, I should have made this a 3, but. Oh.
Point one, I put that.
Point one. Oh, I was gonna say. Victoria, you said it was point one, that's 335.
Okay, I still got the wrong answer. Sometimes my calculator just does that though.
Okay, let's bring it back here. What's my R? 16. What's my theta? 5, 5, or 6. Now, some of you were trying to convert some of this, which you don't need to do in this case. Okay? I've given it to you in radians. Easy way to tell something's in radians. Doesn't have pi in the answer. Doesn't have pi. If it has a pi in it, you're good. You don't need to convert it. If it's in degrees, it's going to have the degree symbol after that. If there is no degree symbol, assume it's in radians. Okay? So now we just plug it in, right? So area is half of 16 squared times 5, 5, or 6. So if I do that, 16 squared is what, 256? Is that right? Yeah. Half of that's 128 times 5, 5, or 6. Right? Now, can you plug that straight into a calculator? Sure. Otherwise, you can divide by 2. Make this 64. 64 times 5 is 320. 320 pi over 3. Now, if you left it like this, I'm perfectly fine with that. 320 pi over 3 centimeters squared. Why do I have squared there? Because it's the area, right? Area has to be squared. If not, if you took it to a decimal, what do we get? 335.1 centimeters squared. Either of those are acceptable answers for
Wait,
area. And it has to be squared. Why does it have to be squared again? Because it's area. Area is always square units. Okay, so just to recap before I give you the homework, and I have to put this up on Schoology yet, the section that you're going to be working out of. So in this lesson, you need to start working on the unit circle, working to memorize that. You need to know both degrees and radians, how to convert back and forth, and then you need to know how to find area of a sector and an arc length. Okay? The practice I want you to do, and again, I have to share this yet, so it's not out there yet. I will put it up here as soon as I'm done. Okay? We're going to do page 348 through 349. And you are doing problems 16 to 32 evens. Those are really quick conversions. Just lots of practice with that. Then I want you to do 34, 37, 38, 43, 46, and 52.
Due next month.
Okay,
For what?
this will be due,
Don't say
what's
this.
today, Tuesday?
Monday.
Okay, tomorrow we will be starting section 2. I'll take questions on this. We'll do section 2 as well tomorrow. You've got 15 minutes in class to work
Well, let's
Okay.
see.
Kyle, do you have
as soon as I get it shared.
a picture of the circle